In this lesson, we're going to be talking about how to factor trinomials. Our first step for any type of factoring is always to look for our greatest common factor. In this case, we have 2x squared minus 20x plus 18. So first we want to see if there is a GCF, and there is, because between 2x squared, 20x, and 18, we can actually factor out a 2. So that 2 is going to be going on the outside. After we take out the GCF of 2, 2x squared divided by 2 means we'd be left with an x squared. 20x divided by 2 means that we're going to be left with a 10x, and then 18 divided by 2 means that we're left with a 9. So what we have is 2 as our greatest common factor times x squared minus 10x plus 9. Next, we want to try to factor the remaining trinomial that's inside. As we can see, there's no leading coefficient. What that means is that there's no coefficient of x squared. The number in front of x squared is just 1. We call that value a. So since a is equal to 1, the way that we can factor this is by finding our factors of our constant, which would be c, in this case, which is positive 9. We want our factors of our constant that end up adding to our middle term coefficient b, which in this case would be negative 10. So what we want to do is we want to find our factors of positive 9, and of those factors we want to find what adds to negative 10. So off to the side, we're just going to want to list all of our factors of positive 9. Well, our options would just be 1 and 9. We would have 3 and 3. Since we're multiplying to a positive 9, we could also have negative 1 and negative 9, or negative 3 and negative 3. From this list, we want to find the pair that adds to a negative 10. Well, in order to multiply to a positive and add to a negative, that means we would have to have two negative numbers. So I can eliminate 1 and 9 and 3 and 3, because it's not going to add to a negative 10. So what I have for my list then is which of these pairs, negative 1 and negative 9, or negative 3 and negative 3, add to a negative 10. Well, that ends up being our negative 1 and our negative 9. As a few tips as you're factoring is that if our constant is positive, so if that c is positive, but our middle term coefficient b is negative, then both of your factors are going to have to be negative, because a negative times a negative is going to be a negative, and then a negative plus a negative is going to be a negative. If your last term, that constant c, is positive, but b, our middle term coefficient, is positive, that means that your factors are both going to be positive. If that constant is negative, but our middle term coefficient b is positive, then the factors are going to be positive and negative. So one's going to be positive, one's going to be negative. But if that middle term coefficient b is positive, that means that the larger number gets the gets the positive. If c is negative and b is negative, so if our constant is negative and our middle term coefficient is negative, that means that the larger number gets the negative. So knowing those tips can help with your factoring. So once we find the pair that works, so in our case are negative 9 and negative 1, because negative 1 times negative 9 gives you a positive 9, but negative 1 plus negative 9 gives you a negative 10. Then we can set up our factors. So our 2 is going to stay on the outside, and then we are going to have our x squared is going to get broken down into x times x. We're going to have an x in each of our factors, since x times x is x squared. For our 9, negative 9 and negative 1 in either order will multiply to give us that positive 9. And then as the remainder of our check, our negative 1 and our negative 9 added together will give you the negative 10 in terms of your middle term coefficient. You can always check this by distributing. So if I did x times x would give me x squared, x times negative 9 would give me negative 9x, negative 1 times x give me negative 1x, and then negative 1 times negative 9 gives me a positive 9. What ends up happening then is that negative 9x and negative 1x add to that middle term of negative 10 that we needed. And then finally, you could distribute the 2 through in order to get back to your original. So if there's not a leading term coefficient, then we can just find what multiplies to our constant and adds to our middle term coefficient. Next, we want to talk about our perfect square trinomials. So we still have our 3 terms, but now we can see as one big difference that we have that leading term coefficient. First, again, we always want to look to see if there's a greatest common factor. In this case, between 9x squared, 42xy, and 49y squared, there is no greatest common factor, which means that we still have that leading coefficient of 9 that's going to cause us some trouble. So in order for a trinomial to be called a perfect square trinomial, it would have to be in one of two forms. The first would be if it's in a squared plus 2ab plus b squared form, or if it's in a squared minus 2ab plus b squared form. As a hint to see if it's in this form, you want to look at your first and your last term. So in this case, the 9x squared and the 49y squared. If each of those terms are perfect squares, that might be a clue that your trinomial is a perfect square trinomial. So the fact that 9 is a perfect square, 3 squared will get you 9, and that 49 is 7 squared, that's a clue that this might be a perfect square trinomial. So first, to determine if it is a perfect square trinomial, we want to identify what a squared and b squared are. So a squared, in this case, is just equal to 9x squared. And b squared is equal to 49y squared. Once we figure out a squared and b squared, we can then determine what a and b would be. Well, again, if a squared is equal to 9x squared, that means that a would have to be equal to 3x, because 3 squared is 9, and then x squared, x quantity squared, would equal x squared. Same idea then for b. If b squared equals 49y squared, b would equal 7y, since 7 squared is equal to 49. Another way to do it would be to take the square root of each of them. So the square root of 9 is 3, the square root of 49 is 7. So first we need to identify what a squared and b squared are so that we can then figure out what a and b are. Next, we want to determine if the middle term gives us that form of 2ab. So the question is, if our middle term, which is 42xy, we need to determine, is this equal to 2ab? If it is, then we have a perfect square trinomial. If it's not, then we don't. So we just want to figure that out. So we have 42xy. The question is if this equals 2 times the a that we just found, which was 3x, times our b, which is 7y. So again, we want to figure out if 42xy is equal to 2 times 3x times 7y. Well, 2 times 3x is going to be 6x. 6x times 7y is going to end up being 42xy. So our current middle term coefficient of, our current middle term of 42xy does equal to ab. As a result, that means that what we have here is a perfect square trinomial. If it is a perfect square trinomial, then it can be factored. And the way that we would factor it is that if it's a perfect square trinomial of the first form, a squared plus 2ab plus b squared, then it would factor into a plus b quantity squared. If it's of the form a squared minus 2ab plus b squared, then it would factor into a minus b squared. So note the only difference between these two forms is the fact that the middle term is either positive or negative. Well, in our case, our middle term is positive, so that means we're going to be able to factor this into a plus b squared. Well, our a we already found is 3x, so that means we're going to have 3x. Since our middle term is positive, we're going to have a plus, and then our b is 7y, so this is going to become 7y squared. So our factored form would be 3x plus 7y squared, since this was a perfect square trinomial. And again, you can multiply this out to see that we will get back to the original, either by identifying this as a special product, or you can write this out as 3x plus 7y times 3x plus 7y and distribute it. So our last type of factoring our trinomials would be factoring trinomials with a leading coefficient. Again, our first step is to determine if there is a greatest common factor, which in this case we don't have because we have 4x squared minus 13x plus 12. There is no number that I can take out from all of them, and they all don't have a variable in common. So the next step is that since we have a leading coefficient, again an a number in front of x squared, we can't use what we did in the first example of finding what multiplies to the last term and adds to the middle term coefficient. We also This is not a perfect square trinomial, although my first term looks like a perfect square, 4x squared. I can rewrite that as 2x in terms of a. But then the 12 is definitely not a perfect square, so it's not a perfect square trinomial. So now we have the situation where we still need to try to factor it. We have a leading term coefficient, we don't have a greatest common factor. So what we do is we use factor by grouping, or sometimes called the AC method. So in order to use this, our first step is to multiply a times c. So again, this idea of multiplying the first times the last. So we're taking the 4 and multiplying it by the negative 12. So 4 times negative 12 would end up being negative 48. Our next step then would be to find the factors of what we just found, negative 48, that add to that middle term coefficient, which we right now have as negative 13. So similar to what we were doing in the first example, but it's going to be a little bit different. We have quite a few more steps to do. But we have this negative 48, and we want to find the factors of negative 48 that add to the middle term coefficient of negative 13. Well, in this case, that ends up being negative 16 and a positive 3, because negative 16 plus 3 gives you negative 16 times positive 3 gives you negative 48, and then negative 16 plus 3 gives you the negative 13. Now that we've found our factors that multiply to negative 48 and add to negative 13, we want to rewrite the original expression using the factors that we just found. So from here, we're going to keep the first term of 4x squared. We're going to keep the last term of minus 12. But the middle term is going to break down into those factors that we just found. So the negative 13x is going to break down into a negative 16x and a plus 3x. So what we've done here is that we've actually made the trinomial into a 4-term polynomial. And that's going to help us because now that we have that 4-term polynomial, we can actually use our factor by grouping. So we're going to group our first two terms together. So we have 4x squared minus 16x, and then our second grouping of the positive 3x minus 12. So within each group, we want to factor using greatest common factor. So in our left-hand group, the GCF of 4x squared minus 16x would be 4x, which means that we're left with an x minus 4. The GCF of our positive 3x minus 12 would be a positive 3. So again, we're left with x minus 4. If we're correct, we can see that we have the same factors inside the parentheses, the x minus 4. So again, using greatest common factor, again, the GCF of our entire expression would be x minus 4. So we have x minus 4, and then our second factor of 4x plus 3. So this would be our fully factored form if we have a situation where we have our leading coefficient with our trinomial. So it is more steps. The alternative to doing this factor by grouping or the AC method is to use trial and error, which is perfectly fine as long as you understand how to do that.